Hello everyone, this is Heading Tian. This video, let's learn chapter 8.3, complex numbers in polar form. We will learn 5 objectives. So this video will be a long video. The first one, plot complex numbers in the complex plane. So before we start the complex numbers in complex plane, we have learned the imaginary number in the algebra. So what is the imaginary number? Imaginary number is I. I equals square root of -1. So how about I squared? I squared is -1. How about I cubed? That's -I. How about I to the 4th power? That's 1. So what is the complex number? The complex number has the form like z equals a plus bi. So it has 2 parts. The real number parts, that's the a, and the imaginary number part, that's the real number b times I. So how to plot this number z equals a plus bi? Let's see. Plot the complex number in the complex plane. So let's draw the complex plane first. The plane is like this. I think my pen needed new batteries. So this horizontal line we call the real number axis. I put real number axis here. And the vertical line, this is the imaginary axis. Since we have learned that, we have talked that a is the real number, that means this horizontal line, that's a real number axis for a, and this part is on the imaginary axis. So if the point is a, b, for example, from here to here is a, and from here to here is b. So the point here is a, b. And this also means a plus bi. This is I. Okay, so this is a way when we see the complex number and then plot this number in the complex plane. You plot it as a, b. Remember, this one is the imaginary axis. So let's see the example graph the complex number in the complex plane. So we have 4 numbers, the complex numbers. First, let's draw a plane, the complex plane. This one, A is 3, B is 4. So for example, 1, 2, 3. So this is 3, 4. Go up for unit. For example, 1, 2, 3, 4. So this is 3, 4, 3, 4. And also that means 3 plus 4i. Second one is b minus 2i. That means a equals 4, b equals -2. So this is 3, this is 4. And then go down to unit because this is minus 2i. So here is 4, -2. That means 4 minus 2i. How about -5? So -5 is a real number. That means -5 plus 0 times I. That means it's -5, 3, 4, 5. So here is -5. And then 0 times I. So I don't need to move up or move down. Just stay here. The point here is -5, 0. And then write it down like -5 plus 0i. The last point is -2i. That means this one equals 0 minus 2i, right? A is 0, so b is -2. So is that the point here? that's 0, -2. So this point is 0, -2. So also can write it down like 0 minus 2i. Okay, let's move on to see modulus or magnitude. The meaning of modulus, that's the distance between the 0, 0 to the point AB. So let me read it. The modulus is the distance between AB and 0, 0. So for example, the point in the complex plane, this point is AB. The modulo means from here to here, the distance from here to here. So how to find the distance? So if I have known z equals a plus bi, that means the distance from 0 to AB, the point, is square root of a squared plus b squared. It's the Pythagorean theorem. Okay, let's find the modulus for z equals 3 minus 4i. So the modulus of z equals, so you see this seems like absolute value, but it that means modulus. So square root of a squared plus b squared, that's 5. Oh no, 5 squared, because 3 squared plus 4 squared, that's 25. So I better write step by step. Okay. So 3 squared plus -4 squared equals square root of 25 equals 5. And then what's the modulo for this z? Let me see why the color changed. Let's see. Trace it. Z equals square root of -8 squared plus 2 squared. That's 64 plus 4. That's square root of 40. Oh, sorry. That's 80. 68. That's what is that? So 68 over divided by 4, 1, 4, 28, 7. That's 2 times square root of 17, because 4 can go outside of the square root. And let's move on to see next part. Oh, why the z is there? So how to get rid of the z? Oh, eraser. Okay. Okay. Oh. Okay. Write the polar form of a complex number. So if I have just like a real number xy plane, x and y. So if a point here is A, B, and then this angle is theta. So before we have learned that how to use cosine and sine represent AB. So the opposite of theta is the y's value, right? Because it's the distance from here to here. That means y's value. So that's B. And then this one is A. So that's the point from here to here is R. So the distance from here to here is R. So let's say cosine theta equals A over R, right? A over R. And then if I'm looking for A. So A isolates the A equals R times cosine theta. And then sine theta equals B over R. So B equals R times sine theta. And the point is AB. That means AB also can express that like r times cosine theta, r times sine theta. Do you still remember the unit circle? Unit circle, the r is 1. So the point on the any point on the unit circle is cosine theta, sine theta, because r is 1. If r is not 1, so it's r times cosine theta times so r times sine theta. So if I have a point z in the imaginary system, I mean the complex plane, is A and B. And the A also can be replaced as R cosine theta. B is R times sine theta. So what's the next step? So I have learned Z equals A plus BI. If the A is this term, B is this term, so the Z equals R times cosine theta plus R times sine theta times I, right? Just to plug in the number value of A and B. So I have the new expression. This is a polar form of this complex number. So I can pull out the R because R, they all have R in these two terms. So we pull out the R, and then in the parentheses is cosine theta plus sine theta times I. We prefer to put the I in front, and then times sine theta. This is a Z. So let's see, they gave you Z equals R times cosine theta plus I times sine theta. We'd better not box it because this box seems very pretty. So here shows you the A equals R times cosine theta, B equals R times sine theta, and plug it in the expression of Z equals A plus BI, and then pull out the coefficient R. We got this expression. Okay, let's move on to see next part. So if there is so there provide you the complex number like this, and then can you convert it to the polar form? That means polar form. I hope I can still use it before I finish this video. So there's no battery for my pen. So polar form Z equals R times cosine theta plus I times sine theta. So we need to find the R and also find the theta. If we can find theta and R, so this is the expression for the Z. So how to find R and theta? So right now we have the Z equals -2 plus 2I. So I'd like to plot the point first. This is the complex plane. A is -2, so 1, 2. For example, this is -2. And B is 2. So it's here is -2, 2. Okay, so the point is here. And can you find this is R? Oh, sorry, this is theta. And R from here to here. Do you still remember R equals square root of A squared plus B squared? That's -2 squared plus 2 squared. That is 4 plus 4 is 8. Square root of 8. Oh, that's equals 2 square root of 2. And the second step, let's find the theta. So the theta, how to find the theta? So you can memorize that. Tangent theta equals B over A. So B is 2, A is -2. So some students will ask why tangent theta equals B over A. So for example, if I have a point here, because this is simple angle, let you understand well. So the point here is AB, and theta is here. So the height of this point, or I say from here to here, that's the distance of B. So I put the B. From here to here is A, and then tangent theta equals B over A, right? So if I'm looking for theta, is that the tangent, inverse tangent B over A? So by this way, I can find the theta. That's the reason why I have tangent theta equals B over A. So tangent, so what is B over A? B is 2, A is -2, that's -1, right? B 2 over -2, that's -1. And then come to see the graph. So if here a tangent theta equals -1, that means reference angle is pi over 2 over 4. That means from the initial to this terminal is 3 pi over 4. So 3 pi over 4. That means I have the r and the theta. Z in the polar form equals r is 2 square root 2 times cosine 3 pi over 4 plus I times sine 3 pi over 4. Okay, let's see next one. So first plot the point in the complex plane. So A is 8, for example, this is 8. And then -15, that means going down 15 unit. For example, this is 8, -15. And then this one also is 8 minus 15i. Okay, so we are looking for the r and also looking for the angle from here to here. So this is a theta. So r, how to find the r? The square root of a squared plus b squared. A squared is 8 squared plus -15 squared. So what is that? So can we use a calculator? So 8 squared plus -15 squared. This one, and then square rooted is second. This one, highlight this one. If you don't have this function, just click this number and under your square root. That's 120. Is that 120? Let's try again. Second square root. So 8 squared plus, because -15 squared, that's 15 squared. 15 squared. 17. Where is my mistake here? Oh, I see. Here should be plus. Why I put multiplication times multiply. So be careful here. When you compute that, look at your check. Go back to check your answer. This is 17. So put 17 here. Make a better 17. Okay, we have the r. Let's find the theta. Theta. So tangent theta equals b over a. What is b? B is -15. A is 8. So here is -15 over 8. Can we use so from here to here is tangent theta equals -15 over 8. So can we use calculator to find the theta? Do you still remember, if we use calculator, if the angle in the fourth quadrant is, so it will give you the angle like this, because the tangent is from here to here, or from here to here. If in this quadrant, they only provide you the negative angle from initial go clockwise, go here, So even we got from the calculator, if say alpha equals inverse tangent -15/8. They gave you the angle from here to here. That's a negative angle. So but I'm looking for this one. Is that means if I know the positive value of this, I use pi minus this. So that's the angle from here to here. That's one way. Or I just write down the reference angle of this one. That's the positive value of this, because tangent is odd function. That means negative of this value equals the reference is a positive. So it's negative tangent inverse -15. Oh no, come back. 15/8. So negative canceled out is positive. Inverse tangent 15/8. That means I can find the acute angle or the positive angle for this reference angle. If I have this, I can find this angle by using theta equals 2 pi minus reference angle, right? So let me clear this area. And then, so the theta equals 2 pi minus reference angle. So it's 2 pi minus tangent inverse 15/8. Let's use a calculator. 2 pi second. So make sure your mode is in the radian form, because 2 pi is radian. So when you do the calculation, second mode, do the calculation, be careful, you must be the radian mode. So 2 pi, 2 times pi. Pi is here. Look at this button, this here, pi. So use second exponent sign. That's 2 pi. And then minus tangent, inverse tangent, sorry. Second tangent inverse. That's 15 divided by 8, close the parentheses, hit enter. That's about 5.2 if we just keep one decimal. So that's about 5.2. We have the r, we have the theta. So so we write the polar form. Z equals r is 17. So cosine 5.2 plus I times sine 5.2. Okay, let's see next one. Convert the polar from a form, to rectangular form. Rectangular form, that's Z equals A plus A BI. So convert it to this one. So this one is easier because I can plug in the actual value for the theta and then convert an A. Look at this example. So can I distribute this 4 in the parentheses? Let's see, what is that? Equals, first we distribute the 4 times cosine 120 degrees plus 4 times, I can move the I to the back. So sine 120 degrees times I. Is this one the A part? Is this one the B part? Yes, so just plug in the value of 120. So where is 120 degrees? It's in the second quadrant. So from here to here is 120. What is the reference angle? That's a 180 minus 120. That's 60 degrees. 60 degrees. So cosine cosine 120 in the second quadrant, ASTC, it must be negative cosine 60. I'm doing the reviews. So 4 times sine 120. So in the second quadrant, sine is positive. So positive sine 60 degrees times I equals, so negative cosine 60 is negative 1/2. 4 times negative 1/2 plus 4 times square root of 3/2I equals negative 2 plus 2 square root of 3I. So A is negative 2, B is positive 2 square root of 3. This is a rectangular form. Next one, compute the product and the quotients of complex number in polar form. So if the first complex number is z sub 1 equals r sub 1, cosine, I just say 1, cosine theta 1 plus I sine theta 1, z2 equals r2 times cosine theta 2 plus I times sine theta 2. When I multiply z1 and z2 first, multiply the r1 and r2 together. And then next term is in the parentheses is brackets cosine. Because this is plus, this is multiply. Inside is plus theta 1 plus theta 2. And then another term is I times sine theta 1 plus theta 2. If division z1 divided by z2, so the r is r1 divided by r2. And then cosine theta 1 minus theta 2 plus I times sine theta 1 minus theta 2. So let's use a formula to calculate to compute some examples. So this one, they give us z1 and z2. Find z1 times z2. So z1 times z2. So multiply the r together. 4 times 2. 4 times 2. And then in the brackets, I have cosine. 4 pi over 3 plus pi over 2 plus I times sine 4 pi over 3 plus pi over 2. And then simplify this. This is 8 cosine. What is that? So 4 pi over 3 plus pi over 2, they have same denominator, that's 6. So 8 plus 3, that's 11 pi. So that's 11 pi over 6 plus I times sine 11 pi over 6. So this is the polar form. Oh no. Okay, let's move on to see next one. Next one is division. Z1 and Z2. What is Z1 divided by Z2? That's the R over R, 4 over 12. And then in the brackets, we have cosine. So 15 minus 285. 15 degrees minus 285 degrees. And then plus I times sine 15 minus 285 degrees equals 1/3 times cosine. So this one is 270 degrees. Oh, sorry, negative. Plus I times sine, negative 270 degrees. And one important thing here. Theta is between 0 and 2 pi. This is negative 270. So it's not in the domain 0 to 2 pi. That means I need to convert this angle to 0 to 2 pi. So let's see where is the negative 270. So it's clockwise. It's going to this direction. It's from here to here. Okay, I got here. That means in the counterclockwise direction. That's from here to here. That's 90 degrees. So this one is 1/3 times cosine 90 degrees plus I times sine 90 degrees. So that's the answer. Let's move on to see next one, compute the powers of a complex number. This one we call the De Moivre's theorem. And this one also it's just the formula we have learned about the product of the complex number. Why? Because in the product of the complex number, we have learned, for example, if I have a z, how about z times z? That's r times r, right? Because they all have the same r. And then in the parentheses, cosine. So theta plus theta, because for each z, they all have theta. So theta plus theta. And then plus I times sine theta plus theta, theta plus theta. How about I have another z? I continue to have another z cubed. And that means I multiply by r here again. That means r cubed. And then cosine. So in the parentheses, I need to add another theta. It's 3 theta plus I times sine 3 theta. And then close the parentheses. If I continue to do that, I have z to the nth power equals r times so this is the expression of the z. So z to the nth power equals r to the nth power times cosine n theta, because theta plus theta plus theta, and then continue to plus another theta. Totally we have n times theta. That means n times theta, and then plus I times theta n theta. Let's use the formula to solve the examples. So if the example is the z equals this stuff, and then z to the 4th power, let's find the result, and then convert it to the rectangular form a plus bi. So I can say let z equals 5 times cosine cosine 75 degrees plus I times sine 75 degrees, and then z to the 4th, that equals r to the 4th, and then cosine 4 times 75 degrees, and then plus I times sine 4 times 75 degrees. Let's see, what is that? So 5, oh, sorry, this is a 4th, because r to the 4th power to the nth power. So that's 625. And then cosine. So 75 times 4. So 300 degrees plus I times sine 300 degrees. So it's asking us to convert to a plus bi. That means I need to plug in the value of cosine 300. So where is 300? Is here. The reference angle is 60. So 300 from here to here. So ASTC, cosine here is positive. So positive 6 cosine 60 of plus I times sine 300. In this quadrant is negative. So negative sine 60. Negative sine 60 is negative square root of 3/2. So let's simplify this. Distribute the 625. That's 625 over 2 plus this one, that's minus because we have minus sign here. Minus 625 square root of 3 over 2 times I. So A is 625 over 2. B is negative 625 times square root of 2 over 2. Sorry, square root of 3 over 2. Let's compute this one. And this one, some students may use just to compute this one by hand. That's negative 3 plus 3i times negative 3 plus 3i. Got the result of this, and then continue to multiply by negative 3 plus 3i, and then continue to multiply another one, and then last one is negative 3 plus 3i, and totally I have 6 times 1, 2, 3, 4, 5, 6. So it's time consuming. It takes a long while to get a result. So we can convert this to the polar number. Oh, sorry. To the polar form. To the polar form, and then to the 6th power, we can find it. Convert it to the A plus BI form. So let's see. So let Z equals negative 3 plus 3i. So let's find the polar form first. Where is the Z? So negative 3, 3. Negative 3, 3 is here in the second quadrant. So let's find the R and also find the theta. So R equals square root of A squared plus B squared. That's square root of 18. You can also simplify this one to the 3 times square root 2, or you just keep this value. And then second, we want to find the theta. That's tangent theta equals B over A. B is 3, A is negative 3, is negative 1. That means the reference angle is pi over 4. In the second quadrant, negative. So theta equals 3 pi over 4. So in the polar form, that's Z equals R is square root of 18 times cosine 3 pi over 4 plus I times sine 3 pi over 4. And then this is Z. Z is not pretty. So Z to the 6th power, that means this one to the 6th power. That's 18 to the 6th. Square root of 18 to the 6th. So the square root, that means 1/2. The power to the 1/2. And then 6. And then cosine. This part means 6 times 3 pi over 4. So 3 pi over 4 plus I times sine 6 times 3 pi over 4. And then, so 6 times 1/2, that's 3. So 18 cubed times cosine. So what is this? It's 2 times 3. Oh, no, 3 times 3. That's 9 pi over 2 plus I times sine 9 pi over 4. Do you still remember I mentioned that the theta must be in 0 to 2 pi or 0 to 360 degrees. So this one is too big. It's more than 360 or 2 pi. It's because let me write down. So 9 pi over 2 equals 8 pi plus pi. over 2, correct? This one is 8 pi plus pi. And then 8 pi over 2, that's 4 pi plus pi. That means I can subtract 4 pi because the period for cosine and the sine, they are 2 pi. So I minus 2 times 2 pi minus 4 pi. The point is still be at the same point as the 9 pi over 2. That means pi is the point where is the 9 pi over 2 is located. Oh, sorry, not that point. So the pi is from here to here, right? The point must be here. That means 18 cubed times cosine pi over 2 plus I times sine pi over 2. Oh, why I say pi over 2 is the point pi. Sorry. Pi. And then plug in the value of cosine pi. So cosine pi is -1. Is -1. And then sine pi is 1, right? Oh, sorry, it's 0. It's 0. So this one equals 18 cubed. Let's use a calculator to find which is 18 cubed. Cubed, you just add a power button here. So click this one and hit 3. Hit enter. That's 5832. 5832. Okay. So that's the rectangular form, a plus bi. So this is a. You can also just add 0i, or you just say 5832. Next one is find the nth roots of a complex number. So before we learned the nth power, and right now find the nth roots. So before is z to the nth power. Right now is z to the 1 over n, or is nth root. So if z to the nth roots, that means we have n solutions for this one or for this one. They are same. So let's see the formula the book provides us. So if the z equals r times cosine theta plus I times sine theta, n is greater than or equal to 2, z has n distinct nth roots. It tells you that totally they have n solutions. That means n distinct nth roots of the form w sub k equals n the nth roots times cosine theta plus 2 pi k be divided by n plus I times sine theta plus 2 pi k over n. K is from 0 to n minus 1. What's the meaning of this? W sub k is the general solution for each root. For example, the first root is w sub 0 because the k is starting from 0 and then end at n minus 1. Even you see the last one is k equals n minus 1, but from 0 to n minus 1, totally there are n items or n, so totally number is n numbers. That means by this way, we can find all n solutions. So for example, the first solution for this one is w sub 0, and then plug in the 0 in all the k terms. And be careful here, n is find the nth root. So if say find the z to the 5th root, the n is 5. N is 5. And then for the z to the nth to the 5th roots, the first solution is w sub 0 and then r nth roots and then cosine theta plus 2 pi. Right now, first solution is k equals 0, so this term is 0 over 5. And here is the same, theta plus 2 pi times 0 over 5. And so also, if you are using the degree form, replace the 2 pi, we can use 360 degrees. 360 degrees here. Okay, let's use the definition, the formula to solve the question. This. Find the 6 roots of 64 over the sets of complex number. Write the result in rectangular form, a plus b. So they give us z equals 64 plus 0i. Oh, this is not given. The given is 6 only for 64. So it's over the complex number. That means over the complex plane. So that means z is not only 64. That's the 64 plus 0 times I. That means to the so 1/6 power. That means z to the 1/6 power has 6 solutions. So if you only have 64, some students told me, can I use this? And then I got 2. This is only 1 solution. You must have 6 solutions. That means you can't have this. So let's convert this number into the polar form. So the polar form first. This is 64. Oh, I see. It provides you the picture here. Let's use the better picture here. So it looks much better. So this point is 64, 0. So convert it to the polar form. Why they give you the polar form directly? Because we are looking for r and theta, right? The r is from origin 0, 0 to the point here. So the distance from here to here is at 64. So that's the r. And what is the degree of this? That's 0, right? From initial to terminal is still this point. That means theta is 0. Okay, let's see. Right now I know the z equals 64 times cosine 0 plus I times sine 0. This is not theta, that's 0. 0. And how about W sub 0? That's the first k equals 0. That's the first solution for the z to the 1/6 power equals sorry, this must be 64, not 65. 64 to the 1/6 power, and then because this is n, and then cosine. The n is 6 because the n depends on the given information to the 6th power. 1/6. Okay, 6th root. Sorry. So the theta is 0, but I need to put the 0 here, plus 2 pi k. And then plus I times sine 0 plus 2 pi k. So this is a general solution, because if I plug in 0 here, I just put 0 here. So the first step, I better to write the general solution. So for the k equals 0, let's plug in 0 here. So 64 to the 1/6 power, that's 2, right? Let me make sure. So 64 to the 1/6 equals 2. Yes, that's 2. So cosine, so this term is 0. That's 0, right? And then if here is 0, is sine 0, I times sine 0. And the cosine 0 is 1, that means 2. And this part is 0, that's just 0, so that's 2. How about W1? Because next one is W1. 2 is still 2, because this term is 2. And then cosine. So if here is 1, k equals 1. 0 plus 2 pi, that's 2 pi over 6, that's pi over 3. Plus I times sine pi over 3. So this one is 1/2. That's 2 times 1/2. 1/2 plus this is square root of 3 over 2. That's square root 3 over 2i. And then distribute the 2. That's 1 plus square root of 3i. And then W2 equals 2 times cosine. So k is 2. So if k is 2, is 4 pi. 4 pi over 6. So that's 3, 2. That's 2 pi over 3. Plus I times sine 2 pi over 3. What is that? So what is the cosine? 2 pi over 3 is here. From here to C. Cosine here is negative because A, S, T, C. So cosine is negative. That's 2 times negative cosine pi over 3, and that's 1/2. And then plus, because here the sign is positive, that's sine pi over 3. That's square root of 3 over 2i. That's -1 plus square root of 3i. And then W3 equals 2 times cosine. So plug in k equals 3. So the 6 pi over 6 is pi. I plus I times sine pi. That's cosine pi equals -1. And sine pi is 0. So I times 0 is 0. Let's see, that's -2. W4 equals 2 times cosine. So k equals 4. So 2 pi times 4 is 8 pi. 8 pi over 6. 3, 4. That's 4 pi over 3 plus I times sine 4 pi over 3. What is the pi? 4 pi over 3. Let's see. So this is so that's here. For example, pi over 3. So in the third quadrant, and then in the third quadrant, A, S, T represent with pi over 3. The cosine sine, they are both negative. So it's 2 times -1/2. minus I times square root of 3 over 2. Or you say plus I times negative square root of 3 over 2 is the same. So that's negative 1 minus square root of 3i. The last one, why I say this W5 is the last one? Because totally we must have n solutions. First one, second one, third one, fourth one, fifth one. This is the last one, sixth one. So 2 times cosine. So plug in k equals 5. So 2 times 5 is 10. 10 over 6, that's 5 over 3. Space. Let me draw the picture here. So it's 5 pi over 3. From here to here is 5 pi over 3. That means here is pi over 3. And ASTC. So cosine is positive in this quadrant. So that's pi. Oh, I better write down the 5 pi over 3 there. So 5 pi over 3 plus I times sine 5 pi over 3 equals 2 times, because in this quadrant cosine is positive, so positive cosine pi over 3, that's positive 1/2. 1/2. In this quadrant sine is negative, so minus I times square root of 3 over 2, because the reference angle is pi over 3. So negative square root of 2, square root 3 over 2. This one distribute the 2. That's 1 minus square root of 3i. So look, they are all distinct solutions. So 2, 1 plus square root 3i, and this one, they are different. So you can't just say the root of the sixth root of z equals 2. I say like this. You can't say equals 2. Equals 2, that means in the under the real number system, but this is the complex number. Even it's 64, but still that's a complex number. So there are 6 roots. Let's continue. I think this video is very long. Let's continue. This is the last question. I'm so happy. Example, find the fourth root of negative square root of 3 minus 1. Oh, minus I over the set of complex number. So fourth root, that means there are four solutions. Write the result in the polar form. So the picture gives you that the point is here because A is negative square root of 3, B is negative 1. So how about the angle theta and the distance from here to here? So R is easy to compute because R equals square root of A squared plus B squared equals, so the square root of this is 3, square root of this is 1. So 3 plus 1 is 4. Square root of 4 equals 2. So R is 2. How about the theta? Tangent theta equals B over A. B is 1. A is square root of 3. They are all both negative. So the value is positive. Equals square root of 3 over 3. So from this one, can you find the theta? Yes, because I know the reference angle of this must be 30 degrees. So let's say 30 degrees. So the angle from here to here is 180 plus 30. That's 210 degrees. That means the z equals the r times cosine. Cosine, the theta is 210. 210 degrees plus I times sine 210 degrees. So the next step, we want to find the general solution for the k, oh, sorry, the z to the 1/4. The general solution, we put the GS, and that's equals the the fourth root. 1/4 times cosine. The n is 4. N is 4. So theta is 210 plus 2 pi k. Because here is degree form, that means I can change it to 360 degrees. 360 degrees. And then times k. Then plus I times sine. 210 plus 360 degrees times k over 4. So what's the first solution? First solution is k sub 0. Plugging k equals 0 in the general form. That means 2 to the 1/4 power, and then cosine. 0 here, that's 10. So 210 over 4. Let's use calculator. Let me go back to see the question. So they only ask you the complex number. Write the result in polar form. That means I don't need to convert it to the a plus bi. Just leave it like this. Just do some simplification, and then we don't need to do too much work. So let's see what is 210 over 4. 210 over 4. That's 52.5. So 52.5 degrees. Then plus, let's fix this. I times sine 52.5 degrees. So what is the W1? Equals 2 to the 1/4 times cosine. So here k is 1. That means let's use a calculator. That's 210 plus 360 equals this divided by 4. That's 122.5 plus I times sine 122.5 degrees. W2 equals, so plug in k equals 2. So 2 to the 1/4 cosine. So if here is 2, so 360 times 2 is 270, 720. So, or you use calculator to compute, plus 360 times 3. Oh, times 2. Sorry, make a mistake. Times 2. That's this one divided by 4. That's 232.5. 232.5 degrees plus I times sine 232.5. And then W3 equals 2 to the 1/4 cosine. So plug in k equals 3. So use a calculator. Clear up. So 210 plus 360 times 3 is 1290 divided by 4 is 322.5. 322.5 degrees plus I times sine 322.5. 22.5 degrees. So can I continue to do this? W sub 4? No, because we already found 4 solutions. 4 solutions. That's the end, because the k is starting from 0 and at n minus 1. N is 4, so n minus 1 is 3. So we can't use the method to find W4 because W sub 4 is not a solution for this example. So I can clear up this side. Okay, I'm done with this class, and then I will change my battery of my pen. I hope you understand everything in this class, in this lecture. If you have any question, please let me know, and have a good one. Bye.